definitely the first problem of the sheet is about x defined as 2e by 3 factorial plus 4e by 5 factorial, 6e by 7 factorial up to infinity, and we seek to find 0 to x fy log x to the base y dy y greater than 1, etc. Now, let's simplify matters here. Let's simplify x. From this, I might as well take 2e common. Up to infinity, right? Which is like 2e summation r by 2r plus 1 factorial r equal to 1 to infinity. Yes or no? That's what this is. Isn't it? 1, 2, 3 r, and this is 2r plus 1, 2r plus 1, etc. What you might want to do is allow this 2 to go inside, right? For reasons not difficult to fathom, 2r plus 1 minus 1, so that I could divide, and I'm expecting a telescope to follow. I'm expecting a telescope to follow. Now on dividing, 2r plus 1 by 2r plus 1 factorial will give me what? 2r? 2r? And 1 by 2r plus 1, right? That's what I'll get. So this is like e times summation 1 by 2r factorial minus 1 by 2r plus 1 factorial, r equal to 1 to infinity. Yes or no? Which is e into look, 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial, and so on and so forth. This is what happens, right? Do you realize e power x is 1 plus x square by 2 factorial plus up to infinity? Put x equal to minus 1, e power minus 1, 1 minus 1, 0. That will give me 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial, and so on and so forth, right? So this will become 1 by e. This is e into 1 by e, that makes it 1, right? Which means in this integral, x is 1. Log 1 will be 0. This hardly is a problem of definite integrals. X equal to 1, log 1, now whatever fy be, this integral is 0.
Is it condition y is greater than 1?
Does not matter.
No, but here it's like 1, like y varies from 0 to 1 given y greater than 1.
Why?
Greater than 1.
This is not even relevant. Don't bother about it. Clear? Let's move to the next problem. Problem 2, part 1. We need to show 0 to pi by 2 f of sine 2x sin x dx equals 0 to pi by 4 root 2 times f of cos 2x cos x dx, 0 to pi by 2 f of sine 2x cos x dx, right? All right, very clearly, we go from here to here. 0 to a, fx dx is 0 to a, f of a minus x. That's what we do here, right? So the required integral I, 0 to pi by 2, f of sine 2x sine x dx is 0 to pi by 2, replace x by 90 minus x, right? So f of 2 90 minus x sine 90 minus x dx, right? 0 to a, replace x by a minus x. This will become pi minus f of pi minus 2x, f of sine, I'm so sorry, f of sine of pi minus 2x. Right? Pi minus 2x, that will make it sine 2x, f of sine 2x, and into cos x. So 0 to pi by 2, f of sine 2x into cos x dx. This is how it goes. Now, we have to now bring in a root 2. We have to now bring in a root 2. So if this is equal to this, then each will be equal to half their sum, right? In which case, f of sine 2x will be taken common, and sine x plus cos x can be written as root 2 sine x plus pi by 4, or could be written as root 2 cos of x minus pi by 4, one way or the other, right? So if this is equal to this, then each will be half their sum. So each is half of 0 to pi by 2 f of sine 2x sine x plus cos x. Now see, what we need is cosine. So this sine x plus cos x, either I can write as root 2 cos x minus pi by 4 or sine x plus pi by 4. What would you prefer? If you need a cos x, you will prefer cos x minus pi by 4, right? So this sine x plus cos x I can write as root 2 cos x minus pi by 4. You realize that? This plus this. So root 2, so that root 2 comes here. Yes or no? Now, cos x means, I would want to make x minus pi by 4 my subject of integration, so that this will become like a cos t, right? Let me make x minus pi by 4 my subject of integration. So when I do that, can I remove the clutter from here? So if I chose x minus pi by 4 as some t, so when x is 0, t is minus pi by 4. So this would be 1 by root 2 minus pi by 4. When x is pi by 2, t is plus pi by 4, right? Into f of sine 2 x is t plus pi by 4. Dx is the same as dt. Yes or no? All's good? This then is like 1 by root 2 sine 90 plus 2t, which is cos 2t. Sine, this will be sine 90 plus 2t, which is cos 2t. Yes or no? So f of cos 2t, see, all is falling in place. Cos 2t. Of course, there is a cos t which I missed. This cos t dt, cos t dt, minus pi by 4 to plus pi by 4. Hey, minus a to plus a. Do you realize This is an even function in t. Replace t by minus t, it remains unaltered. Since it's an even function in t, minus a2 plus a would be twice 0 to a. Because see, have I told you that result? So it's going to be twice this, 0 to a, right? So 2 by root 2, 0 to pi by 4. Two by root 2 is root 2. And now you can replace t by x. How does it matter? Right? Now you can replace t by x, y or z. Does not matter. Right? Which reduces to this. Clear? Part 2. 0 to pi x sine x f of sine x dx is pi by 2 0 to pi f of sine x dx. Very simple, isn't it? 0 to a, I can replace x by pi minus a. So this is pi minus x, 0 to pi f of sine x, x by pi minus x, sine x will remain sine x, f of sine x dx. If this is equal to this, then each will be half their sum. This plus this, x and x will get cancelled, right? So each will be half their sum, half of 0 to pi f of sine x dx, which is what this is. Fairly simple, isn't it? I'm assuming you got all of this right independently also. Everything that I have done so far. 3, part 1. Integral 0 to n pi, right? 6 pi. 0 to 6 pi mod cos x dx. What's the periodicity of mod cos x? Pi. Right? So n times t, n will come out. So this will be 6 times 0 to pi mod cos x. Right? So you would break it down into 2, 0 to pi by 2 and pi by 2 to pi. Why? Because from 0 to pi by 2 cos x is positive. From pi by 2 to pi cos x is negative. So break it down into 2 integrals, 0 to pi by 2, in which cos x is positive. So mod cos x will be cos x plus pi by 2 to pi. In this interval, second quadrant, cos x is negative. So this will be minus cos x, etc. Now you can evaluate this. Right? That's 6 part 1. You would have got it right on your own as well, isn't it? 3 part 2, e power x minus box x dx, x runs from 0 to 25. This is e power fractional part of x, isn't it? Periodicity of fractional part of x is 1. So this is e power fractional part of x has periodicity 1, 25 times t. So this 25 will come here. So this is 25 times 0 to 1. And in the interval 0 to 1, fractional part of x is x. Fractional part of x is x. When x varies from 0 to 1, fractional part of x is x. So this is 25 times 0 to 1 e power x dx, which is 25 e minus 1. Right? I was hoping you would have got this right as well. Sounds fair? F is a function satisfying f of a plus x plus f of x is 0. For all real x, f satisfies this condition. and there is an integral b to b plus c fx dx. We want to find the smallest positive value of c. We want to find the smallest positive value of c for which this is independent of b. Now, if f is periodic, then c will be the fundamental period of f. If c turns out to be the fundamental period of f, then that's the smallest c for which this will be independent of b. Did I tell you that result? B to b plus t would be independent of b. So let me see if this is periodic. Then the fundamental period of this function would be the value of c. That will be the value of c. Now, f of a plus x is 0. Replace x by x plus a. Replace x by x plus a in this. So you get a plus 2a plus x f of a plus x as 0 on replacing x by x plus a. Now if I subtract this and this, then what do I get? I get f of x is f of x plus 2a. Yes or no? When I subtract this minus this, then I get f of x is f of x plus 2a. That means the fundamental period of f is 2a. That's the fundamental period of f. And therefore, c must be t, the fundamental period, 2a. C can be any integral multiple of t also for this to be independent of b. C must be equal to 2a. Is that okay? Some of you have an exam tomorrow? Haryana, what do you have? Oh, I'm glad you still came. Good. Huh? It's coming by courier. Delay हो गया. कब है? परसों. All right. देखते हैं. चलो. So C must be 2A. You really expected me to get that? I have to be explicit about my jokes now. You would want to write sin x plus cos x as? Root 2 sin x plus pi by 4, right? So write sin x plus cos x as root 2 dx minus pi by 4 to n pi minus pi by 4, right? Let me make x plus pi by 4 my subject of integration, st, right? So then obviously dx will be the same as dt. This is root 2 integral mod sin t dt. Now when x is minus pi by 4, t is 0. When x is n pi minus pi by 4, t is n pi. T is n pi, transforming to the t domain, right? Yes or no? And what's the periodicity of mod sin t? Pi. So n times t, so this n will come out. So n will find a place here. In the interval 0 to pi, sin t is anyways positive. So mod sin t is the same as sin t. Integrate minus cos t. Minus cos t from 0 to pi will give you 2. Right? So this will become 2 root 2 n. Simple, na? Zero to y We want to show d2y dx2 proportional to y. We want to establish that d2y dx2 is proportional to y. Now what is dx dy? By the way, again, draw that sense of distinction. This y is not the same as this y. Now just to make sure that you know, to avert any accident, let me call it 9t squared and dt, so that you know, you don't fall in the trap of assuming that this y and that y are the same. I've mentioned that very explicitly to you, right? Now dx dy, there are three parts. In the first part, you differentiate this with respect to y, which will turn out to be 0, 1, right? In the second part, you replace this t by this y and differentiate y with respect to y. Third part will be 0 because it's a constant, right? So dx dy would be simply, first integral will be 0. Remember Leibniz rule? The second part, replace this t by this y, root 1 plus 9y squared, and then differentiate y with respect to y, which is 1. That's dx dy. Take the reciprocal dy dx, because we are seeking to find d2y dx2. So dy dx then root 1 plus 9y squared, differentiate a second time, chain rule, d2y dx2, first differentiate with respect to this, 1 by 2 root 1 plus 9y squared, then 1 plus 9y squared with respect to y would give me 18y dy dx, 18y, and then y with respect to x will give me this, yes or no, right? Now see, dy dx by root 1 plus 9y squared is 1, isn't it? Dy dx divided by root 1 plus 9y squared is 1. Dy dx divided by root 1 plus 9y squared is 1. So dy dx divided by root 1 plus 9y squared, that's going to be 1. So this will be simply 9y, because dy dx by root 1 plus 9y squared, that's 1. So this turns out to be 9y, so d2y dx2 proportional to y. Isn't it?
I can just solve y equal to e bar 3x minus
Understand, but I didn't want you to do that. I didn't want you to do that. I wanted you to apply Leibniz, because I could have given you a function which you couldn't have integrated, right?
standard formula देख के याद आ गया.
Right. But I see those of you who are tempted to integrate this. That is not what I expected you to do. Nothing wrong about it. This one you can integrate, so you know you could exercise liberty. But in the event you can't integrate a function, you would run into a soup. You know, if you try to integrate this and then find y as a function of x explicitly, not only will it result in loss of aesthetics, it could be more prone to errors, because greater number of operations, right? So best not to do that. It comes as simply as this. Clear? There is a curve y equal to fx from x squared to x cubed. So on this curve y equal to fx, I want to find the equation of the tangent at x equal to 1. On this curve, I want to find the equation of the tangent at x equal to 1. What will be the slope of the tangent at x equal to 1? The value of f dashed x at x equal to 1 will give me the slope of the tangent at x equal to 1, right? So obviously f dashed x means I need to differentiate this to find f dashed x and then plug in x equal to 1. And again, noteworthy, this x and this x have nothing to do with each other. They had nothing to do with each other. Again, to avoid any confusion, let me call it t to power 5. Over a period of time, don't do all this. Mentally conceive what is happening here. Don't do all this. Now, in this case, you can't integrate this. 1 plus t to power 5, it's non-integrable. It's non-integrable. So if you have attempted to integrate this, God bless you. You integrated this? No, that's all right. Don't take him that seriously, Abhishek. Huh? So I'm going to apply Leibniz rule. F dashed x There'll be three parts to that. The first one, differentiate 1 by root this in terms of x, which is going to be 0 because t and x are independent entities. In the second part, I'm going to replace t by x cubed, isn't it? I'm going to replace t by, is it t to the power 5? Yes. I'm going to replace t by x cubed and then differentiate x cubed with respect to x, right? So t by x cubed, which is 1 by root 1 plus x power 15 into 3x squared. In the third part, I'm going to replace t by x squared. This will become x power 10 and differentiate x squared with respect to x. So that will make it 2x, right? And that comes married with a minus sign. So minus 2x divided by root 1 plus x power 10. That's why I told you, breed good familiarity with Newton's Leibniz rule of differentiation under the integral sign, That's extremely important. All of us enjoy that tremendously. Teachers and examiners alike. Because this gives you so much of flexibility to operate, so many wonderful things you can do with this. Therefore this automatically becomes the favorite of everyone. So you should breed enough familiarity with differentiation under the integral sign, right? The Leibniz rule. Now, what are we seeking? F dash 1. Slope of the tangent at x equal to 1 would be f dashed 1. Would be the slope of the tangent at x equal to 1. F dashed 1, 3 minus 2, 1 by root 2. Isn't it? Put x equal to 1, 3 minus 2, 1 by root 2. That's the slope of the tangent. Now, when x is 1 on the curve, when x is 1, what is y? 0. Because it's 1 to 1. Y 0. So 1 comma 0 is the point on the curve, on this curve. And the slope of the tangent at that point is 1 by root 2. So the equation of the tangent that passes through this point has this as its slope is going to be what? Y minus 0 equals m 1 by root 2 into x minus 1. That's the equation of the tangent at 1 comma 0. Finish, right? Reason I'm just moving fast because some of you have an exam and the fact that you came, I feel obliged. I might as well want to let you go early so that you can take your physics. Or are you prepared for your physics exam? No, not yet. There is nothing like a perfect preparation anyways. And that too, school exam. We want to show, if this is phi x, we want to show phi double dashed plus phi is minus cos x. Phi double dashed. Sorry for that misprint. So phi dashed, that's going to be minus sine x minus, now I want to differentiate this with respect to x. There will be three parts to this. In the first part, the integral will show up 0 to x. I am going to differentiate this with respect to x as if t is constant, So this will give me 1, 0, phi t, right? So this will give me simply phi t dt. In the second part, replace this t by x. And that's going to be 0 then, x minus x, 0. Third part anyways is 0 because the lower limit is constant. So that's what you get as phi dashed x. And now, phi double dashed x is minus cos x. Differentiate one more time. And this will be phi x simply. This will be phi x. So minus phi x. So which on transposition gives me phi double dashed plus phi equal to minus cos x. Transpose this on this side. Right? All's good? 0 to x. 0 to x mod sine t plus mod cos t dt. We want to show g of x plus n pi by 2 equals g of x plus g of n pi by 2. This is what we want to establish, right? Clear? What is g of x plus n pi by 2? That's going to be 0 to x plus n pi by 2. Mod sine t plus mod cos t dt. This could have been written as what? 0 to x mod sine t plus mod cos t plus x to x plus n pi by 2 mod sine t plus mod cos t. Ah, good. This will be g of x. This will be g of x. Plus, now, mod sine t plus mod cos t has a fundamental period pi by 2. Has a fundamental period pi by 2. So, x plus n times t. So, this should be independent of x. So, you can plug in x equal to alpha, beta, gamma, eta, theta, mu, nu, xi, phi, epsilon, whatever, or x equal to 0. Right? Might as well use x equal to 0 in this, because this will be independent of x. Right? So, this then is g of n pi by 2. This then is g of n pi by 2, isn't it? Simple, now? But thanks so much for coming. You know, I feel a little guilty also, but at the same time, I feel obliged that you came despite, most people won't come if the next day is physics or chemistry. Can I wipe this off? When are your exams? So, it was Ram Rahim then, and now it's Raj Rahim. Sorry. Sorry. But if you really observe him keenly, you know, see, he's retaliating this time. He's expecting something very dangerous to come up. So, you know, at the very onset, he's taking a very defensive stand. No. All right, let's move to 10. F is even, defined and integrable, and f has a periodicity 2. F of x is f of x plus 2. T is 2. Gx is 0 to x ft dt, and g1 is given to be a. 1, we want to show that this gx is odd. That means if I can show that g of x plus g of minus x is 0, then the problem is solved. If I can show that gx plus g of minus x is 0, right? Now g of minus x, let me start with g of minus x. That's 0 to minus x ft dt. Let me try and create, if this is t varying from 0 to minus x, but minus t varies from 0 to x. So let me try and make minus t my subject of integration. Let me try and make minus t my subject of integration. Now, f of minus t anyways is not an issue. That's the same as ft. Why? Because f is even, right? So what I do is, I write this as f of minus t anyways without having to compromise. This is d of minus t with a compromising minus sticking out, right? So while t runs from 0 to x, minus t runs from 0 to x, while t runs from 0 to minus x, minus t runs from 0 to x, right? Yes or no? So then this is like minus fz dz minus t as z, where z runs from 0 to x. Right? Hey, but this you realize is the same as gx, Because you replace this t by x, it will still be g of x. So do you realize that this is gx? So minus gx, so g of minus x turns out to be minus g of x, causing g to be an odd function of x. Right? This is minus g of x, isn't it? So far so good, right? G of x plus 2, I want to show, is gx plus g of 2. G of x plus 2 is gx plus g of 2. Now what is g of x plus 2? 0 to x plus 2 ft dt. This I can write as 0 to x ft dt plus x to x plus 2 ft dt. How about it? This is g of x. Good for us. Right? This is g of x. Now, f has a periodicity 2. So this must be independent of x. I can plug in x equal to 0. Right? Because this is independent of x, might as well use x equal to 0 for this. And when I use x equal to 0, this will become g2. g2, yes or no? So this is what we set out to prove. G of x plus 2 minus g of x is g of 2. Now, given g1 as a, I want to be able to find the value of g of 2. Okay. Either I can go from here and find that by plugging in x equal to minus 1, plug in x equal to minus 1, then I get g of 1 equals g of minus 1 plus g of 2. But g is an odd function of x. So g minus 1 will be minus g1. And g of 1 is given to be a, so g of 2 turns out to be 2a. Now, without using this result from first principles, let's go from first principles, g of 2 directly, because it's not like, this problem would come before this problem, right? So let me find g of 2 independently. Can I remove the clutter from here? G of 2 is 0 to 2 ft dt. I want to find g of 2 in terms of 0 to 1. 0 to 1 is what I want to read. So I want to halve the length of this integral. 0 to 2a, 0 to 2a. So what I do is, this is 0 to a, f of t plus f of 2a minus x, so 2a minus t dt. Yes or no? Yes or no? But f has a periodicity 2. So f of 2 plus minus t is the same as f of minus t, is the same as f of minus t. But f is even, so f minus t is the same as ft. But this is a, right? This is g of 1, this is g of 1, which is given to be a. So that makes it 2a.